Again, thank you very much for your kind introduction. And I also appreciate you and the Zhongmin's kindness to invite me through your program committee to join this meeting. I thought I have been retired from my work and I will retire from this association. But again, you are very kind to ask me to talk about history. So it is very enjoyable. In order to put up the history, I have to look up a lot of background information, pick out some pictures. So that's what make me feel fun again. So I appreciate the opportunity. So the goal of today's talk basically is not a scientific talk, but I will using some slides to, number one, give some acknowledgement for many of you contribute to initially was a triennial hand and wrist biomechanics meeting. Now we have a formal association called HWBI now, and also using this opportunity for younger generation in the group to see how much fun we have in the past, and hopefully you can pick up the ball and to run this and increase more interest in this, not only for our own fun, eventually can benefit the patient. That's the ultimate goal. So with this in mind, I will just quickly go through this presentation. As my good friend and many of you know, Dr. Paul Brand, he was a well-known hand surgeon, especially in the tendon transfer for leprosy patients. Also, he wrote up a very good book. He gave this to me called Fearfully and Wonderfully Made, talking about the human body. It's not just come out as an accident. So it's all creatively made. So hand is a very complicated structure within our human body, which almost consists of all the nature of the body, ranging from anatomy to circulation, nerve system, everything. Of course, for the hand and wrist biomechanics, we start our research with a scientific curiosity. Eventually, we found some clinical application. Vice versa, for some audience in the group here, they are clinicians. They start with a scientific, with a clinical questions, then create a scientific curiosity, so that we doing the research. Eventually, back and forth. This is how the whole field get to progress. And roughly saying biomechanics can be kinetics, and the material properties. So these are the basic tools help us to better understand the biomechanics of hand and wrist. Ultimately, we can provide a service to our clinical colleagues to do the prevention, diagnosis, and treatment. Of course, it's more than this. For example, how do we improve the performance? So on and so forth can be part of this type of research as well. So in terms of hand and wrist biomechanics, I always like to divide the different type of research. You can dealing with the old topic with old technology, but we new old topic with new technology. Vice versa, you can have a new topic with old technology and a new topic with new technology. Each of these has a benefit. For example, people say old topic, old technology may not be that attractive. On the other hand, quite a lot of study initially been performed with a very limited sample size. Now, if you have better resources, you'll be able to repeat the same study with larger sample size, get more conclusive finding. Definitely is important. Of course, it's very sexy or very novel to have new topic, new technology, but this will not always be true. Quite often, we will have old topic, but a new technology, we reinvestigate the topic. So today, I will quickly just using 3 examples to illustrate the history of this. Start with the force analysis. Second one will be the motion analysis. And the third one, I will talk about how does the technology drive all the research. Start with the force. Of course, this is our friend, Dr. Paul Brand again. Beside that book, he wrote Fearful and Wonderfully Made. And this is also a very useful book called Clinical Mechanics of the Hand. He wrote this and he did a lot of dissections, try to understand the muscle function in order to benefit his procedure for tendon transfer. So in fact, this technology is not very new because all the dissections he developed. Eventually, when he visited us one time, we showed him this book at our rare book collections at Mills Library. Dr. Nicholas Steno, in fact, had all the drawing he thought he invented, but they did this in 17th century. So in other words, talking about the history, the history is way back to 16th century, if not even earlier. So this is very interesting. In talking about hand biomechanics, like we cannot forget about Dr. Landsmeer. Of course, he was from Leiden, Holland, Netherlands. He did extensive anatomical study of the hand. And later on, he transformed them into mathematical model to represent the function. So that was, in my mind, one of the earlier functional anatomy. He is one of the anatomists, but focus on function as well. Of course, his student and his colleague, Dr. Kauer, did the same thing, but on the wrist joint. Oops, something wrong, let me see. Let me try again. Okay, so maybe I forgot if I skipped slides. Anyway, so the whole things come, Landsmeer did all the modeling. And later on, of course, we developed all the mathematical model. We did all the calculation from the theoretical point of view, calculate all the muscle forces, and also try to do experimental and using either EMG or we have a transducer, we can directly implement this transducer into the tendon doing the force measurement. And of course, most recently, Professor Angela Kedgley's group is doing more in-depth modeling and also in-depth EMG validation. This is a very encouraging. And I like to see Angela is our new secretary-elect. She will contribute to this association in the future. We're looking forward to that. And of course, with all this calculation, hopefully we can get all forces in the tendon and muscles and forces in the joint. So eventually this help us, this is the implant design. In fact, this was the motivation. Initially, I was hired in 1975 by Mayo Clinic. As early 70s, Mayo started with a joint replacement of human body. I was hired to be in charge of development of a joint for the upper extremity. And I found out basically there was no data for us to do the design. So that's why basic research started at that time. But eventually we get involved with all the design of the implants. So not only the implant application, the model eventually can be used to do other study. For example, as I mentioned earlier, this is a study we collaborate with Dr. Jiang Wu and Dr. at Butik at NIOSH Research, try to look at how does the model can design a new pipette to prevent injury. And of course, the force analysis, if you further going into detail, then you can look into the using finite element model. In this case, we call the rigid body spring model. We model the bone as a rigid body, the ligament and cartilage as a spring model. Based on that, we can calculate the stress. Using this model, we can look problem, for example, different way to treat Kimbach disease. How do we unload the stress in the neurone? So this has been done by Dr. Frederick Schön. Professor Schön was from Belgium, and he should be acknowledged. He is instrumental to start with this triennial hand and wrist biomechanics meeting in 1992. After his fellowship at the Mayo Clinic, he went back to Belgium and got funding from NATO. That's how we had that first meeting organized with all the people interested in the topic invited to get together. So he should be really credited for all this process. Okay, so let me move quickly to the second topic. I will show a little bit history about the motion study, specifically pick up the wrist joint as an example. Of course, at that early 80s, people are very interested in wrist because wrist is a very complicated joint, also create a lot of a clinical problem. At Mayo, I start with the hand research. Then later on, my colleague Bernie Mori interested me to study elbow. So I jumped from hand to elbow. And Dr. Lincha and Dauben, Lincha, of course, collaborate with me already. Dr. Dauben was also a hand surgeon Two of them are responsible for the definition of DCVC. For those of you interested in research, probably recognize this classification. He asked me specifically, why do you skip wrist joint? You jump from hand to elbow. I said, I don't know. He said, if you are interested in wrist, I'd be glad to do some research in wrist. He said, do you know we are well known at Mayo Clinic for wrist joint, especially their definition of this. I said, I did not know. So that time, of course, when I look at the wrist with all the 7 carpal bone with 27 joints, I say it's almost like a Rubik's cube. It's almost impossible to move them into the right direction. But nevertheless, we start our research in wrist. Of course, at that time, we developed the biplanar X-ray to do the functional anatomy, also the in vitro kinematic study. Then subsequently, we introduced the technology of magnetic tracking device. So this hopefully can make the measurement much easier and faster. Of course, each system has their advantage and disadvantages. Of course, Fred Warner is the person really focused on the wrist. He has the most sophisticated wrist simulator way back in the late 70s, early 80s. And subsequently, he modified them with all the robotic control. So there's a very sophisticated system. So many of the research in the wrist area, especially carpal kinematics, we should credit to his group, not only himself, but also his colleague, Dr. Schultz and Dr. Palmer. So in this particular group. And Professor Warner, we should give him also the credit to keep this association going. He was member of the first meeting in 1992. All the way through, based on my record, he has never missed any meeting. As you know, until 2007, we had a meeting in Japan. Before that, we had a meeting every 3 years. Later on, we have meeting more frequently. But as I know, Fred participated in all of this meeting, and he keep this meeting going. So I should really give Fred the credit to keep this society or association alive. Of course, at that time, his colleague, Ronit, Professor Wolsten, was also participating in this wrist kinematic study. Her beautiful presentation today, or yesterday, also remind me the important clinical application. When we have very sophisticated model, how do we make it clinically applicable? And Professor Wallenstein currently is elected as a treasurer for this association. We were looking forward to your contribution in the future. And Veronica eventually using the first one, probably introduced using CT to do the in vivo kinematic study in order to understand the wrist kinematics. Again, her beautiful lectures this morning summarize many of the interesting topics associated with carpal kinematics. Of course, she is one of the members for this we call the councils, and her advice to this association and the serving of the association will be expected. Thank you, Veronica. Okay, of course, that scientific technology keep moving, and currently not only using CT, but using time sequence CT called 4D CT, will be able to look dynamic imaging of the carpal bone in vivo. So with all this new technology available, definitely we will be able to do more. Then we should give also credit to Dr. Trey Crisco, Professor Crisco, not only his great contribution in wrist kinematics, of course, his famous finding associated with dart throwing motion, define the plan where the least motion taking place. This is very important after you have ligament repair. This is the right plan for you to do the rehabilitation and not to impose too much stress on the ligament. On the other hand, he also interested in other joint, especially the CMC joint. I assume he will be the chairman of this association in the future. He is the chairman elected, and he will introducing more new topics associated with the finger joint, especially in the basal thumb joint in our program. So again, looking forward to your great contribution in the coming years. So Mark Garcia, of course, he gave the keynote lecture the day before yesterday. And of course, he has been very instrumental for the couple kinematics. Not only that, but he always tried to make the topic simple so you'll be able to understand. And again, I thought his explanation to me of VCDC from hand surgeon is very complicated. Basically, he say it's a Noonan trapezium ligament, Noonan scaphoid ligament. Depends on which ligament been damaged, then you end up with this or this. So this has been in my mind throughout the years. And of course, he always applied this clinically. He developed techniques to do the test for surgeon and keep doing research. And he has been a friend as well for many, many years. So let me quickly move to the third topic. I will just demonstrate how the technology has been evolved and which can also facilitate, also guide the direction of research. This is an old slides in one of my old publication, which was at that time we collaborated with the Stanford Research Institute using ultrasound, try to see if we can do the measurement of an anatomy, functional anatomy by using non-invasive ultrasound technique instead of using biplanar cadaver study. So as you can see at that time, in order to do ultrasound imaging, you have to embed the specimen into the water in order to not dissipate the sound wave. So this is back then. Now this is now. Our chairman, Professor Zhongmin Li, has been using ultrasound extensively. For example, just in this case, beautiful ultrasound imaging, you can see the transverse carpal ligament clearly. You can do all in vivo measurement without doing dissection. So this is a typical ultrasound application using the B-mode scanning. And Dr. Zhongmin Li, again, since his participation in Tokyo and formally formed HWBI, his contribution to the association is enormous. Again, probably should give the most credit for organize this meeting and organize in the meeting in the past 4 or 5 years. So ultrasound of not only give you the B mode, of course, people are creative, try to using spectral tracking, using Doppler. So in this particular case, we be able to use an ultrasound to monitor the movement of the tendon, movement of the nerve. So we'll be able to give us further measurement of the biomechanics parameter in vivo, either in patient or in normal subject. So this really opened the door for additional research. So I have to show these slides. Professor Su and Professor Ko in their research group in Taiwan at the National Cheng Kung University in collaboration with their superb ultrasound researcher, Professor Huang. So they're using the so-called high-frequency ultrasound vector Doppler imaging. They are not only be able to look at the gliding or sliding of this the tendon, they also be able to monitor the displacement of the tendon during the hand movement. You can see the displacement is not uniform in one direction. In other words, when you glide your tendon back and forth, different region has different amount of rotation also. So this is a new technology, give us additional insight. Maybe this type of rotation within the tendon causing additional pathology or causing tendonitis, so tendinitis, so on and so forth. So this is a new technology and it could be a new application. Professor Su has been a member of this association for many years, and he organized a meeting in 2007 at his university in Taiwan. And Dr. Kuo is also a partner of his research team, is an OT. He has been very creative by looking at biomechanics for clinical application. And he has been the important bridge to bring the science back and forth between clinical and the laboratory. So finally, of course, the ultrasound technology has been recently used in the so-called shear wave elastogram. Many of you probably using this technology, but if not, basically, this is a technology. You use the ultrasound to measure the wave propagation. In other words, if you create a wave, either by ultrasound beam or by mechanical vibration on an object, then the ultrasound imaging can capture the imaging and calculate the wave velocity. Based on the relationship of wave velocity and also the material property and the density of the material, you'll be able to derive the stiffness or the loss modulus of the material. So this technique has been developed and used extensively recently to study the function of the muscle and the stiffness of the muscle, and of course a tendon. So one of the creative applications by my colleague, Dr. Chunfeng Zhao, is using this technology to look at, is it possible to measure the carpal tunnel pressure? So this is the idea, as you can imagine, if you have a tendon, if it's free on the table, you measure the stiffness. If you put them in the cuff, squeeze them, then you measure the stiffness. Because when you squeeze, you compact the object, so they become a little bit more stiff. So by observing the difference of the stiffness, by using the sway ultrasound shear wave elastogram, hopefully you can correlate the amount of a change of stiffness to the change of the pressure in the cuff. So based on this, he developed this in vitro and calibrated in cadaver, and eventually tried out on the first group of patients. Indeed, you can see the pressure, or in this case, they call the shear wave velocity, compared with a normal subject and with the cadaver, they are indeed elevated. So they are further refined this technique, and hopefully this can be used as an in vivo non-invasive assessment of carpal tunnel pressure. So as you can see, the technology keep moving, and we are open up a new door for new investigation. So quickly, I just show these examples, and there's an abundance of history, even just in hand and wrist biomechanics. We can sit down and spend hours to discuss this. This is the beautiful picture, as Fred showed earlier, and I still have good memory of this group when we met in 1992 at Ganville in Belgium. So many of you are in this picture. And specifically, I should mention about Dr. Kapenji. He was at that meeting. Some of you probably know him because he developed some technique for treating the distal radial ulnar joint problem. But more important is he wrote a book, Physiology of the Joint. He has a lot of insight about the biomechanics. Even he did not do much research, but he does have a creative insight put in his book. And 2012, we had a meeting in Tokyo. At that time, we have a group of people we met. Should we keep doing this triannually? Because some of them, especially Professor Cai, was a colleague of Dr. Zhongmin Lo. He suggests maybe we should form an association, and we should have this meeting more frequently, if not annually or biannually. So we'll be able to have one meeting in the biomechanics associate meeting and one meeting at hand associate meeting. So this is how we form this hand and wrist biomechanics international. And we should really give credit to both Dr. Zhongmin Li and Dr. Cai to get this idea with the help of many of us, including Fred, to get this society going. So in the future, of course, what I can see, this is a multidisciplinary approach. We are focused on biomechanics, of course, not focus only just on mechanics. We have to not remember the bio part is equally important. So in the future, how do we incorporate our biomechanics with life science will be important for more critical application. Of course, the big data is also very challenging. Nowadays, with all the AI technology, many of the problems eventually could be solved, either with individualized medicine, or you try to extend your finding into population. For example, unfortunately, this was just in the poster. I noticed in one of our paper here was from Professor Su's group by a student, Mr. Chen. He, using the AI technology, using the convolutional neural network, they be able to, by looking at the curve, when you're doing a pinch, different object, then they be able to use an AI technology to differentiate the potential problem with the trigger finger or not. And I remember one of his students present another paper. They be able to just look at how you lift up some subject, because they collect a large amount of data. They be able to differentiate what type of diabetes. So there's a lot of futures by using AI technology to help with the differentiation of the groups. So of course we have Tokyo Olympics. When I look at this beautiful globe in the sky, If you do not, I did not have a chance to see that. This group was formed by more than 1,800 drones. Initially, they fly in sky like this, just like their logo. I didn't realize how we progressed. Eventually, they randomly move around, then eventually form this sky. So this immediately gave me the hint what we are doing, maybe still piecewise. Eventually, as Dr. Zhongmin Li asked the question, how much is the neuromuscular part control? I forgot yesterday was the topic because that we only focus on the mechanics part. Of course, the neuro is also important. Eventually, we'll be able to put this together, then we have a clear picture. So this is very interesting. But on the other hand, as I experienced with my student always, the more we know, the more we do not know. Because the more you know, you find out, in fact, the thing is not that simple. So we will just keep searching. That's what makes the research much fun. And we not only see the application, but new discovery. So at the end, I like to introduce these two beautiful ladies, as Fred mentioned about my wife, Sui Qing, and I also mentioned about Magda, is the wife of Mark Garcia. So we are friends for many years, and they are beautiful lady. We travel together for many hand-related meetings. Not only their accomplishment in the world, both of them did a great job, but more important is their testimony. Really teach us how to live our life more meaningful. So we are really appreciate. They are in heaven. My wife passed away in 2010, and Magda passed away in 2014. But we know they stimulate us together. We will do more to help out. So thank you very much for your attention. I wish you all a joyful and grateful person and have a life enjoyable. Thank you very much for your attention, and thank you the program committee for giving me this opportunity to refresh the history of hand and wrist biomechanics. Thank you.